Hello, everybody. Thanks for joining our session, Automating FAIR with an Ontology-enabled data platform. Hopefully, you all came to this room first. There was a little discrepancy between the app and the schedule with which room this was in. So that's why we're just a little frazzled. We just had to move up here pretty quick. Thank you for joining online as well. I'm going to go ahead. Today we have planned a session that's interactive. We're sharing kind of, at Palantir, we have a lot of practice in implementing dynamic ontologies across all types of different domains. And specifically, we want to be exploring how that works in this practice, and we have some interactive activities that we're going to want all of you, and please feel free to engage, ask questions throughout. Okay, so just to introduce myself, I'm Carmen Jenkins. I'm a solutions lead for Palantir. My background is in computer science and system architecture, and also I've been working with IT systems throughout NOAA for most of the last 2 decades. Going to go ahead and introduce my colleague Mackenzie here.
Hi, my name is Mackenzie Kelly. I also work on data solutions at Palantir within our U.S. government federal space. My background is a little bit more from an analyst or operational perspective. And a lot of what I do is really looking at what challenges are standing in the way of users to achieve the outcomes that they want to with their data, and how different ways that we're enhancing the usability of data or applying technologies can help them reduce some of those barriers and achieve their outcomes. This is also my first time at ESIP, so I'm really excited to be here. It's been a great week so far.
Okay, so one of the things we're going to use to try to get some interactivity, both from those of you who are joining from us virtually, as well as those in the room, is we're going to use Pull EV. Sorry to throw another technology at all of you. But right now, just to get started here, just want to get a feel for what's the different perspectives all of you are coming from within the room, and what are you hoping to get out of this session. And so go ahead, you can use that QR code or that URL, plug that in, and you'll be asked those questions. So I'm going to go ahead and try to switch screens. It is not. I have to make it bigger.
This one.
Oh.
Yeah.
Sorry about that. Okay, so I see as people's answers are coming in, data management, seeing stewardship, mapping, research, semantics. So a lot of data focus, obviously, at this conference. Okay, we can go back and revisit that in the meantime. Okay, so we're hearing mostly people learning about how technology can automate FAIR, learn about how other organizations are tackling challenges, and unsure or other. If there's any other things that people want to share, if you're online, if you want to go ahead and just put it in the chat, or if you're here, if you want to raise your hand and share that other, we'd love to hear it. All right. Okay, great. So so used to a touch screen. Just assume. Okay. Okay, now we're going to open up the next question. We want to get a feel for what's your expertise or experience level with ontology. So if you want to go back into that poll EV screen and answer that question for us. Okay, so not surprisingly for this audience who are all, coming here to the Earth Science Information Partners, there's a lot of people who worked on design or had some experience, the majority of people in the room, which is awesome. And so we'll ask those of you with like the most experience, don't all group together when we do our exercise. So it looks like the majority of people are somewhere in the middle, familiar or have some experience. And then we have some people who aren't as familiar at all. And some who are expert level. So great. So we've tried to kind of target this with all these audience involved. If you are one of these people who's more experienced too, please, feel free to like interject or engage and give your perspective and opinion along the way as we work through some of these exercises. Okay. Okay, so first off, we're gonna and again, I know those of you who are more familiar will seem a little redundant, but what we really want to do is kind of level set and get everyone on the same page as far as the terminology that we're using within this session specifically, and some of it might be a little bit different from what other organizations are using. So I'm going to turn it over to Mackenzie here.
Okay, thank you all so much. Like Carmen said, we're gonna kind of walk through like what the ontology concept is and some basic terms are first at a high level, just to sort of provide an even framework before we get into the more collaborative activity. And as we go through each of these concepts, I'm going to use the example of a wind farm, clean energy plant, the Pleasantville wind farm here in Vermont, a fictional plant that is producing wind energy production. So I think a really useful place to start in understanding what an ontology model or concept is and how we're defining it is first taking a look at what a traditional data landscape looks like without one. So if we use the example of the Pleasantville wind farm, you might have these data source systems or sensors that are coming off, say, turbines or components off of the turbines. They're producing data sets, and then those data sets are being interacted with different users at the wind farm. You might have a scientist, for example, who's using different data from these turbines or systems to work on forecast models to predict energy outputs. Or you might have more operational users who are maybe not as technical, they're not working with the raw data, but maybe some sort of curated or synthesized data set. And the information they need is to help them make maintenance decisions and perform routine maintenance on turbines or systems. One of the challenges that we see in an organization like this is that different users are taking the cuts of data that they need or the slices of data that they need for their own work to accomplish what they need to accomplish. But they are maybe not getting the whole context or picture of all the relationships of the data across the organization and not realizing how their outputs or other data that they're generating or actions that they're taking might be affecting other parts of the organization. So for example, if I'm one of these scientists, I might not realize all of the maintenance planning that's happening across this wind farm. And if there's certain downtime that's happening because of maintenance, that's going to affect my forecast models to predict energy outputs. Likewise, if I'm a maintenance technician and I'm trying to plan the most optimal maintenance schedules, maybe I need inputs from the scientists or their forecasts to understand when I should plan those maintenance actions during times where we expect the least energy production. So we can make those trade-off decisions. But that's not happening in a lot of data landscapes that we see in the field. The data is not being mapped and relational in the way that we would see within ontology. So these inefficiencies are starting to arise in different decisions. So that's really what an ontology model is trying to achieve. So if we add an ontology to this data landscape, how does that now change things? It starts pretty much the same. We still have the source systems, the windmills and turbines that are producing this data. The data is still being generated from these systems. But now there's this semantic layer that is performing these automated tasks to model and organize data in familiar constructs that are representing their real world entities. Another term that we might use for this that you hear often is digital twin. So how are we organizing and mapping relationships in data across the organization to reflect these constructs in a way that mirrors how they actually behave in reality? So in this kind of construct, if we take the same scientists and operational users, maybe the scientist is now seeing or getting a little bit more insight into when maintenance is happening, and they can take that data and information as inputs to create more accurate models. Similarly, an operational user, like a maintenance technician, can now have more insight into the forecasts that might be produced by scientists and make more effective dynamic decisions about when to plan maintenance. So really the goal of this ontology data model across a group of many different varied user classes is to provide greater context to every user and to make the relationships between all of their activities more obvious. Okay, so that at a high level is what an ontology is, and that kind of like sets the framework that we'll use for our activity later. But I also just wanted to go over a few elements that make up an ontology. So how do we get there? Starting at the top left, we have the object type. This is your schema definition of the real entity or event that you're trying to describe. You can think about this as your data standard or model. So at a lot of sessions throughout the week, we've heard a lot about establishing data standards and frameworks. This object type is really that data standard that you're defining. It should ideally exist outside of the data and be agnostic to the data. It's not going to be changed by the data. It's just the definition of how you're describing and defining the data that you need to form that object. So for a wind farm, it'll be things like the location. Where is it located? How many turbines do I have? For the turbine, it's going to be, okay, what model or make is it? What are all the components and subcomponents that make up this turbine object? And then getting down into the object and object sets, this is now where we're starting to populate that ontology model and that framework with actual data. So moving from the abstract down into the specific instances. So to populate an object, I would now take data, map that to the model, and now I can connect all the relationships in the data to describe, say, turbine 3. You can probably think about the ontology as like the nouns of the organization. And if the objects are the nouns, then all of the relationships between them or your links are the verbs. So these are the connections that are happening across different objects. If a change happens or an update happens in the data, how does that affect all of the other objects around it? If I am a technician, how does a maintenance action I'm performing then affect all of the other objects in the network of turbines and maintenance actions? So link type is that high definition schema, how we're defining the relationship, and then the link is the actual instance of that. So an employee, Jamal Jacoby, performing an action to fix a hydraulic fault, for example. So these are just some terms and elements that we use to describe the ontology. And now I'm going to hand it back over to Carmen to talk about the activity where we're going to apply this.
Okay, so now here's where you guys are going to, before we go into this, I just want to, I think a lot of this was probably, for a lot of the audience, it was going to be pretty basic, but were there any questions on any of the terminology that we had up here at all, or does that all seem clear to you guys? Okay, looks good. So now what we want to do is take this we have our Pleasantville Power Company. They have this wind farm here in fictional Pleasantville, Vermont. And what they need to do is they need to be able to predict the energy output from the wind farm for the next 30, 60 to 90 days. Using, whatever data is going to help make that better and more accurate prediction. So knowing that we're not expertise in this, we're going to use a lot of assumptions, but the idea here is that we want to go through and explore how we would set up and organize the data for a specific use case like this. In this scenario, you can assume that there's a model exists and that you're going to be feeding into it or inserting it somewhere in your workflow of data. But the first thing we need to do here is split up into about 4 different groups, try to make them equal size. And so we're going to have everybody stand up and move. We'll put one up here in this quadrant, one here in this quadrant, and then and one each in the back tables. So we're going to need to be around a table. So I know it's Thursday afternoon, it's late, but come on, get the energy flowing. And for those of you who are online, can they still hear me?
Sure.
Okay, we're into a breakout room, and we will share with you the URL for a Google Doc, and we're going to ask you to do this activity on the Google Doc. So I'm going to move because the activity has a few different parts that I need to describe. Will you how are you going to? Okay, thanks. Okay.
Oh, that's fine. So when you want to, if you see the broadcast button, you can broadcast a voice message, no filters that they're in.
Got it. But they won't be able to see the slide.
No. So
okay, that's okay. It's not, there's not that much detail on it.
Yeah, we can bring them back, put them out, bring them back, put them out.
Okay. Okay, so before you get, I clicked on broadcast. Do I know if they're hearing it? Because it's not like doing anything. Oh wait, no, okay, never mind. Okay, so before you guys get started, we're not just going to say do the ontology. We're gonna start do it in a few steps. So the first step is we want to work with your team to identify what are the different object types you're going to need. So you can go ahead, leave some space and separate those out a little bit, because we're gonna be trying to identify relationships and stuff in the next step. But just go ahead and just come up with what are those nouns, what are those object types that you would see as being inputs or to this prediction use case. Okay, you guys can keep having your discussions, but we're going to also move on to the next step, which is what's the link type. So you can come up with more objects or change your objects along the way. That's or object types along the way. But what are the link types? How are these objects related to each other that you think you're going to need here?
Like the first thing comes to mind are all kind of
if I need to broadcast that to the room now, should I speak? Oh, you put it. Okay, got it. Thank you. Oh, okay. So when I did it, it wasn't doing anything yet. Okay. Okay. Perfect. And they seem to be doing the activities. Okay, and I know that we are still we're still working on these link types and how we're relating these objects or even on coming up with objects. But the next step, and you can move to that as soon as your group is ready, is to say, this sits outside the ontology. This is the question about how are we going to feed it, which is where are the data sources that are going to feed and populate these objects and links. And this is hypothetical. Think about a business where, you know, how are you getting data from your turbine? You know, where are these data sources coming from to feed these? And they can be external or internal to the business. Okay, we're going to wrap up in about 2 more minutes, and it's okay if you're not done, but we're going to like share the experience that we've had with the group. Okay, I think we're going to take a pause here. It's okay. Nobody is going to take this and try to put it into operations tomorrow. So just a theoretical exercise to have the kind of debates and questions and work you go through. At this point, we're going to have someone from each of the groups kind of share their what they came up with and any thoughts on the experience or where you got stuck or the debate, that kind of thing is. So which group wants to go first? Come on up. So I'm going to ask you to come up here to the podium just so that we can, so the folks joining us online can see, and just bring your paper and hold it, and I'll hold your paper for you in front of the camera.
Stop sharing.
Oh,
right.
Thank you. Okay.
Microphone or?
Okay. Yes, why don't you come over there and I can be right here. Let's see if we can get it.
Hey, can you guys hear me? No? Hello?
What? Oh, the swing, okay.
One, two.
Just come on.
All right. Oh, God, I'm like right in the camera.
I'm gonna switch, yeah.
All right, so we don't know anything about wind farms, but we basically started putting together, the kinds of things you need to know, like environmental conditions and all the properties of your turbines and the operational infrastructure that you would need to run that. We're kind of, we go back and forth on whether these themselves are the types or they're sets of types, but sorry, is that okay? But we feel pretty good about the basics here. The second question was the link types, and just sort of with the limited time we were working with, we saw that you would use a lot of the information from here to make predictions, as well as maybe information from here to make predictions on how well your wind turbines would be functioning and outputting, as well as doing schedules for maintenance, when it needs to start and stop and all that kind of stuff, as well as making predictions about damages and repairs and things like that as well, or just plans. The data sources, we have, we put everything in weather, and environmental things, because we know that that is an expansive array of data sources that we, all pretty much familiar with the challenges there. And those would be the ones that would primarily need to be aggregated from many different sources for the question number 3. But we also saw that there was going to be other systems like HR systems, scheduling systems, engineering maintenance type of log systems that would also need to be incorporated. So that's what we have.
Awesome. Anything you want to share about the experience?
My group is awesome.
Yeah, thank you. Okay. Okay. Okay, who wants to go next?
Just pick someone, let's go.
How about the you're gonna go, you want to go? Come on up. They want to see it, or should we just? Oh, I'll put it, you want to come over here? Okay. Yeah.
Thank you. Our group really pulled together to try to discuss this at this time of the day. So we had lots of discussion about, again, the object types, if things should be object types or attributes, but we needed observations and methods and features of interest. So we did have some expertise in our group of working with other data models and observations data models. And also some other things like wind turbines, instruments, what is the time, we want the wind forecast. So then we tried to think of, if those things were in boxes, what would be the links or verbs between them? So measures, has, produces, that's the lines we were thinking along. And then for the data sources, we didn't get to every object type, but we were thinking there could be lots of possible data sources. So it's either like a model that is make the source of the forecast, the instruments, which are the source of the sensor data, or, you know, we're getting a little joking around a little bit at that. The internet is the data source. And I think it was a good exercise in just thinking through what these things could be, but we're very interested in knowing like what they should be, or like what's one way that they could actually be to work and how it could make things more fair. So interested in hearing that.
Thank you. Can we have a volunteer from the online group to share next? And let me go ahead and share that screen.
If none of that group is going to speak up, I guess I can.
Thank
I
you.
didn't hear a volunteer, but
Thank
I'll
you.
wait till you share.
Go for, oh yeah, I'm clicking, let me see.
The one that's here,
Okay, sorry.
and then at the bottom, you grade.
Thank you. Sorry. And just tell me to move up or down along the way.
Okay, so you're fine for the moment. We actually had issues picking out what things were objects versus other kinds of things. And in fact, we started off having issues with what's the question? Because the question, you know, we were trying to figure out, well, do we have to take political things into concern? You know, is this a thing about making money, et cetera? But we finally settled on, you know, that it's really to just predict power generation over the next 30, 60, 90 days. And with that, we came up with objects like the wind farm itself, the turbines that are parts of it. Obviously, you need to have something about meteorological forecasts. The problem in our group was we didn't know a lot about many or any of these things. And so, for example, it wasn't obvious whether the meteorological forecast was detailed enough that the topography was not important as an external entity and set of data. Clearly, there has to be some sort of power model. And then the question is that power model a semantic thing, or is that just, you know, a model that takes some of these other objects as, or instances of objects as inputs? And for example, we also had a discussion of whether nearby structures were big enough to actually have any impact on the power generation. And so consequently, we didn't get much into links types, and we certainly didn't do question number 3. You know, we have link types of, yeah, wind farms contain turbines, and we were just discussing what, you know, if you've got a prediction, it's going to be based on things like your turbines and your forecasts and your topography, and it's going to involve your power model, but we didn't actually get around to figuring out what those link types really were. And we didn't really discuss data sources at all.
Okay, Great. Well, thank you very much. And let's see, we have two more groups. And you can just, oh wait, no, I gotta switch, turn off the screen share. Oh, sorry. Okay, thanks.
Super. So, thank you for that. Yes. Good point. I'm sorry, just.
Yeah, thank you. Okay. All right, sorry.
Yes, so there are, so I think much the same as the others in terms of the objects. There's turbines, kind of debated where the components of the turbines are important objects, kind of how much detail to go into, like blades or generators and so on. There's a sort of transmission system, there's the sort of the energy, the electrical energy, wind energy. There's a transmission system, there's a wind farm as a whole, that's an object, and sites within the wind farm on which there are turbines, and there are lots of sensors all over measuring things, the links.
Yeah, then as far as relationship or link types, we had nested link types where sites and turbines are nested within farms. How spacing, measurement of spacing might impact the turbine efficiency. Forecast will influence wind and how much wind is needed to turn the turbine. So minimum speed as well as maximum speed that would shut down the turbines. Then each turbine is linked to a generator that creates the electrical energy. And then how much energy can be stored and how much can be transmitted to the grid are all things that could be measured and variables in your algorithm.
Yeah, there are various data sources from weather forecasts, kind of plans of the sites and kind of information about the generators that go into the model. And yes.
Okay.
Thank you.
I drew the short straw. So, yeah, we don't have a lot on the paper, as you can see. What we do have an object here and a relationship and another object there. So we tried not to make too many assumptions. In other words, we're not going to try to figure out whether the wind farm is on the land or on Lake Champlain for that matter. It's just a wind farm. So we're taking a very general approach here. And we realize that the length of the blades, for example, and the number of turbines is certainly going to affect all this. And perhaps even the capacity of the transmission lines. But we didn't get into the details of how we would set up relationships on, number of turbines, et cetera. We did want to, though, get the climate prediction in there for climate variables, because certainly knowing or being able to estimate at least what the climate would be could help us there. But we realized too that that's just going to affect the speed of the turbines. And so there might be, a separate entity between wind turbines and then the speed of them. Another assumption is that we would go with transmission lines that could handle maximum capacity expected, unless like there was a tornado or something. And so we went with those kinds of assumptions. And also the length of the blades would we would figure on them being pretty pretty big. And a lot of turbines. So we didn't have a lot here written down, but we're trying to make some assumptions that we can all agree on. And we realized too, the details would have to be filled in, you know, like the relationship between the wind turbine speed and the weather, so that we could make some estimates about how much power we would generate in the near future.
Great, thank you so much.
Cool.
All right, well, thank you very much, everybody, for participating. We did this activity partly because we just want to get the context for everybody in their mind about all the different ways this data can come in, and the fact that this is hard. I mean, even if there's no industry standard for this in the renewable energy community, there's a lot of different proposals, and if you go look, they're going to all look very different. So there isn't a right answer. I mean, but you know, the kind of things that I would just came up with is like, I want to, you know, a maintenance event or a maintenance plan. I want to know when there's scheduled downtime to factor in, and I want to factor that together with, you know, forecasted or climate normals for wind speed. And, you know, these are all coming from different places, or it's probably the historical performance of each of your turbines, et cetera. So all different types of data and sources that are going to be populating that. And I think one thing you can think about is when you think about it from different angles, you're probably not going to get that data model right at first. You start using it for a specific purpose, and you might find better ways. And so that one of the things that we look at is that, you know, you need to be able to change it and evolve it as you use it more. Okay, so I'm gonna just go ahead and skip that because I think let's go ahead and I'm gonna hand it back over to Mackenzie. I'm gonna skip this. Oh, no, you're right. Okay, sorry. Okay, sorry. Okay, so it said this is something, well, we do this specific type of a use case for energy industry as well. But we work across many different industries, bringing together earth science observations, oftentimes with other operational data sets. And as the challenges that Mackenzie mentioned up front, you know, typically the big challenge is having data that is siloed and having data that is hard to use. And I think that makes it basically that you can't use it for decisions. So you're making decisions without you're using the data that's easy and accessible. And so we have found over time that putting this data into a common ontology, into these real world concepts, makes it accessible for users from all different types of backgrounds. And rather than having to go and do one-off studies over here and give a report to another team, you can have many different types of users working off a same set of truth. And so modeling this data and building it into this type of a dynamic ontology really helps achieve the FAIR concepts by reducing the barriers to access and making it more usable and accessible. I'm going to talk a little bit about how we approach this with the with our automated system. So this is one, yes. I am like, you'd think after all this COVID that I would be better at navigating sharing. But
The others, no.
the other Zoom window. Okay. Sorry. Okay. All right. So we basically, automate a lot of this to create tools to allow people to pull this data together from all these different source systems. You think about this hypothetical Pleasantville wind farm. like we said, you may want to connect to like a workforce management or maintenance system to understand, planned maintenance, or a knowledge management system that's looking at, historical maintenance. You may be pulling in data from the nod. If anybody was just at that session, that's telling you, climate norms, and somehow you have to get this to all work together. And so by automating all of this data from all these different types, whether it's these streaming sensor data, or structured data files or legacy systems, pull it together and provide a usable data foundation that can help with decision making. So what you're seeing here in this picture is a lot of detail, because this is typically about the size of a data lineage that we see in our organization. This is actually probably a pretty small one from what we see. When you get in, there's actually usually, tons and tons. So what you see, what we do here is build the tools to automate this from the source systems on the left all the way over to your common ontology, which is what you're seeing on the right over here. And as we do this, we are allowing the introspection of the full data lineage, of seeing where did that data come from, how did it get transformed. So if there's questions about that, super important for decision making to be able to go back and see, how do we come up with that? Is there a better technique, or is there an issue with that? How are we dealing with missing data, et cetera? and having the human ability to interact with the data pipeline versus like a set of scripts that's somewhere that only people who are tech savvy can understand. So the way that we kind of handle that is to have the user interface to the data pipeline. You can click on any of these boxes and bring up the data and view the data set, or view the logic that's doing transformations. And under the hood, one of the things is to have it, use software configuration management process. We look at, versioning of data, versioning of transformations, so that any decision making can be tied to specific versions of the pipeline along the way, and what state that came from. It also, that type of using the like DevOps agile approach allows you to be updating the ontology and the pipelines within the same environment, testing them, and allow for an automated data governance where you can look at what if I'm changing this pipeline here, if I'm changing the way that I'm extrapolating missing data, for example, in an algorithm, that it's properly reviewed before it becomes part of the operational system. And again, having quality checks and controls to deal with, some data didn't load or had an error case, or we are seeing, maybe a source system, sometimes as you upgrade your sensor firmware and it's added a field or changed different fields, or changed a unit, and now everything breaks. And so you can put in those types of checks and have a human alert and be able to interact with that data. And so ultimately, by pulling all that data together, setting up these pipelines so that they're feeding and updating automatically, allowing humans to interact and have transparency for authorized users. And then you can get to that real world concept. So over here, just kind of had some, back to our wind turbine example we have with an example of an ontology for that. So are there any questions at this point? I can see we're tired. It's the end of the day.
So,
Oh, okay. We had different information. So we were, well, I apologize for that. I think, yeah, I'm sorry. We had different information about the timeline, so we did actually, so, you want to, yeah, if you want to go back to the poll EV, if there's any last questions or comments along the way. We want to thank all of you guys for participating, and I hope you guys have a great afternoon.